Good afternoon and welcome to ARTtech seminar at Assembly Summer 2018. My name is Natasha Trygg and I will be your host for today. As the first talk, we will have about the tools of game development and how to make the development faster by Niklas Tanskanen from EFI Code. Niklas, welcome to the stage.
All right. Thank you. Good day, everyone. Thank you for coming. So good to be here at Assembly 2018. Agenda of the day, DevOps. We're going to introduce you to the DevOps culture. Going to introduce you to the DevOps influence development process. We're going to take a look at the deployment strategies that the DevOps brought to you, some metrics, some application building. Today's talk is going to benefit you if you are a software developer, a game developer, a web developer, or an operations guy. I have tried to include as many examples for as many as possible. That's me. My name is Niklas Tanskanen. I'm a DevOps consultant. DevOps consultant is someone who helps their customer to make their organization more DevOps-wise, meaning that they are coaching the people in organization to apply DevOps both cultural and tooling-wise. My strong suits are cloud and CI/CD deployment strategies. This is something that I'm going to share you with today. My first assembly, I believe it was 2006. I was an organizer in the game crew, and I watched the Counter-Strike tournaments and making sure that nobody cheats. Nowadays, everyone just plays Dota 2 or League of Legends, and I have no idea how to play those games. Besides gaming, I do home automation at home. I contribute to open source now and then. This week I'll be building water cooling for my PC. I only have one tip for you guys. If you are planning to have a water-cooled PC, don't do it. It's going to wreck your brains. I come from a company called EFI Code. We are a company of 200 people. We are software developers, consultants, UX people, designers. We are on a humble mission to make product creation fun again. We also have some gaming customers. We have Unity, Rovio, for both which we do DevOps things, and we have Eficode, for which we have been doing some big data things. So what is DevOps? This is from Wikipedia. It says, unifying development and operations to create better software. Every game essentially is a software, so this applies to games as well. DevOps is about mixing people from operations side and from development sides together to create a sort of a mix-up of both sides. In a traditional organization where you have development and operations people separated from each other, in that organization, applying DevOps would mean that the operations people would take more responsibility of the development side, and development side would take more responsibility of the operations side of the product. Implementations of DevOps, they vary a lot. There's no one way to do DevOps. You cannot taste DevOps. You cannot buy DevOps. You cannot just bring a couple of consultants in and tell them, make our organization DevOps. Let's do things faster. I want this DevOps, it sounds so cool. You cannot do that. It starts with the people, and that's why it's so hard. So what does a DevOps culture look like inside an organization? Well, first of all, I think this is the very important part of the DevOps culture, is that they treat their code well. They don't accept circumvented solutions. They create real solutions, no hacks. They maintain their code. They have a stable releases and stable builds all the time in the development. It's not a chaos as it usually is with the development process. You have a builds failing, you have a tests failing. In the DevOps culture, everything seems so stable. They also apply a code review processes, meaning that they allow the team that builds the product allows others to review their code, both machine-wise and people-wise, meaning that the machines will review your code using code analysis tools such as SonarQube, which will tell you how does your code look like, how does it smell. And the people part will tell you, is your implementation maybe good enough? Can there be a better way to solve this solution, solve this problem? And the next part is experiments. DevOps culture pretty much dictates, and in order to have DevOps, you need to have automation. You need to have automation in order to do quality products. And when you have this kind of automation, you're not afraid to try something just really quick. Because you have such full automation in your development pipeline, you can just try something. I believe that building software or building games, it's an artisan work. It's an artist work. And the people in the industry are very creative by their nature. Because they are creative, they get these ideas in their heads all the time. And DevOps culture is something that embraces the ideas, and you shouldn't be afraid to just try something really quick. But if you have a static infrastructure, static pipeline, static development flows, there's little room to test something really quick. And the third part is automate and analyze. Don't do boring stuff, naturally. Automate all the boring stuff in development or in operations. And don't guess. If you have a product in production, whether it's a mobile game, PC game, console game, and you are thinking, how does my game perform? Do people even like it? You cannot just go by your butt. You have to have some data. Let's look next at how does a DevOps influence the development process go. So this is a traditional process. You have your dev environment set up in your own laptop or in a console or in a mobile phone or whatever. Setting up that environment took you a few days since you started. No automation. Maybe a senior guy was standing behind your back and telling you what to do. Click here, oh, this should be fixed, yeah. Then you get the dev environment working. You push some code to the repository. It ends up in a QA environment, hopefully. The testers are going to test your code in the QA environment. They're going to send you some bugs because you created some bugs. Okay, dev fixes it, it ends up in a QA again. And after the testers are satisfied in the QA environment, it ends up in staging, which is a close copy of a production environment. In production environment, in staging environment, that's the next release candidate of your product. And it's tested again, and then the deadline comes, and it ends up in production, no matter the state it was in staging. I see many problems with this approach. Mostly, why just not automate the dev environment creation from the start? If the developer passes some bad code to the QA, which will break up your whole application, whole game, they are stuck with it. They cannot test anything unless you get it fixed right away. And everyone just are standing still until you get it fixed. The staging environment is a close copy of the production environment, but it's not production environment. So why that's there? Because you're never going to get the same results. This is a process influenced by the DevOps ideology. The dev environment is fully automated, meaning that the new guy comes in, there's going to be a few minutes, and they can already push some code to the repository. Fully automated setup of the dev environment is very important when you even think about the employee experience. There are multiple QA environments per change set. When you have a manageable change set, you deploy that to an isolated QA environment. And everyone should have access to that QA environment. And when you have these multiple QA environments, you can test those change sets without compromising other work. And if you broke your own QA environment, the damage is limited to only that change set. I replaced the staging word with Canary. I'm going to go back to that in a bit. But first, what do you need to succeed when you are applying DevOps culture? You need three things. You need a place to run your stuff. Usually that means cloud. But if you are a mobile developer, you should really have access to all the tools that you are required to do your job efficiently. The meaning of either phones in the cloud or hardware phones, or if you are building a backend for your League of Legends application, you need a cloud, you need the infrastructure, and you need resources, and those resources should be available to anyone with the snap of a finger. On top of that infrastructure, you need a world of tools. You need tools that will do the heavy lifting for you. They will compile your code, they will deploy it, they will do test automation against it, and when you say so, they will deploy that to production. And then you need you, or your team. The people who are building the product should also be responsible for running the product. Meaning that there cannot be a wall between the users and the developers, so that the developers just throw stuff over to the wall to the users, and they have no idea, is it even good? Do people like a game? And there are two ways of knowing, do the people like your game? Gonna go back to that in a bit. My 2 cents is that if you want this DevOps culture, you need to show people how good it is before they can accept it. If you just go there and okay, we're going to get rid of these old servers, we're going to push everything to cloud, and by the end of the year, I want this, and that, it won't succeed. You won't succeed. But if you show the people how the automation works and how can it improve your experience as a developer, the people will buy it and will begin to contribute to it. Back to that Canary deployment. So you have this DevOps setup. People are engaged. And you have an infrastructure, you have a world class of tools, everything is good. You have deployed your first version of the application. People like it, but there are a few bugs. And you're planning to fix those bugs. You have tested it vigorously in the staging environment. And you think there's no bugs. It's perfect. Let's release it. And you release the application. And it turns out that in production, it doesn't work the way you want it to be. It's hideous. There's a huge bug in the application. What went wrong? There's always going to be bugs. There's always going to be bugs that will be catastrophic. So how do you make sure that your whole user base doesn't suffer from the bugs? Canary deployment is a method where you release your new version of the application only a subset of your users instead of the whole user base. You might have come across it, for example, in Facebook, if you see some button in your mobile app that others don't, you are subjected to a Canary deployment. Why would you do this? Sounds kind of complicated to release only to a subset of users instead of the whole audience. That's true. It is complicated. But the benefit is that instead of angering 100% of your users, you get a chance to only angry about 10% of your users. Let's look at a few scenarios of the Canary deployment. This is a typical setup of an application in web. It could be a backend to your game or even a website or whatever. You have a load balancer, hopefully in front of few servers. Those few servers serve the same application, and the load balancer equally redirects traffic to all the servers. This is good because you can take one server down and you can do maintenance to it and then bring it back online and nobody notices a thing. The load balancer also is able to just redirect 10% of the traffic to a set of servers that have the new version of your application deployed, while the 90% of the users still stay in the old version of the application. Of course, there's a few problems with this approach, as there is with the Canary reloads. How do you handle schema changes to database? You still have one database behind the application. How do I make sure that once the user ends up in the Canary deployment, that they stay there so that flickering doesn't occur between those two? And is there a rollback plan in change? What if the 10% of the users begin to suffer because the new version is bad? How do you make rollback fast? This kind of approach is also supported in Apple's App Store or in Google Play Store. You can run Canary releases there too, so that the App Store will only release the new version of your application to a small subset of your users. So not everyone will be upgraded to a newer version. But the rollback strategy is still something you need to think about, because you have no way of controlling when your users will upgrade again. If the new version is bad, they must stay there. And even if you do rollback and you roll back to a previous change, doesn't really help, because the users are still in a bad version and they might even not know how to downgrade back to the working version. This is also one of the strategies you can do if you are planning Canary deployments. In this case, the binary is shared, the same binary, the new version is shared with all the clients. And you have a feature toggles inside the application. And you call to your home server and ask which features should be enabled for this user. And then in the application, there could be a simple ifs that if the server says I need to enable this feature, then I will show you that button or whatever feature. So that's Canary deployment. Let's do a simple demo. You guys have your mobile phones, right? Can you help me a bit? Go to this address. And I've set a simple small application there. It's either going to show you a red background or blue background. And depending on the version you get, you're going to see the color And can you show that to the camera, please? 4, 5, 6, 2. All right. It should be 50-50, so something's going on here. But it's a risk while doing those live demos. If you refresh the app, you should get the red or blue, depending on which version is currently serving, which the load balancer is currently serving. So that's Canary deployment. I think that the red version is the correct, is the version 1.0, and the next version after that is the red version. Great. Sounds good. But how do I know that the blue version, which is the next version, works? How do I know? How can I be sure that when I have the Canary deployment going on, I have a 10% of the users using the new app and 90% of the users using the old app? When can I be sure to roll out the change so that 100% of the users use the new app? You have to have metrics. You have to collect data from both the old version of the application and the new version of the application and compare those data. If you did fix to something that was wrong, let's say it's a bug, can you deploy a metric that shows that the problem was fixed? In an action game, the frame per second is a very important part of the player experience. And if I have a bug that it eats up the FPS, did the Canary release to a group that is affected by it, fix it? Is the FPS better now? Is our game more enjoyable with better server tick rate? That would be metric by asking the user feedback. Or did our balancing work? Is the game more enjoyable for the casual ones, and does it offer more challenge for the experienced ones? All these are good metrics, and this is how you should do it when you're doing Canary releases or releases anyway. Collect metrics from your clients and from the server side, combine those two, and do a little data scientist work. And you'll get actual data instead of by going by your gut. Developer experience. This is one of the cornerstones of DevOps. And it's a cornerstone of a happy developer. Metrics are part of developer experience. As I said, the people who are building the product should be responsible for running the product, but they cannot run the product if they don't know what's going on. So collect metrics, how your game, how your application is doing in production, and then you know. Another part of the developer experience, besides running metrics in production, is fast feedback cycles. When you're developing something, and you push the code to the repository, and then you wait. You wait and wait and wait, and there's no feedback until the game gets released, and there's a huge bug in a feature that you made. Yeah, that's the only feedback you're gonna get. A pretty dull life. But instead, what you should do is utilize both human and machine feedback. The machines should tell you immediately that yes, your code is good, it passes our tests, it looks good. Then the team revives it again. Yes, looks good. Let's accept this to our next release. This page intentionally left blank. when you're thinking about feedback cycles and those results from the test automation and from how does your code look like, the speed is essential. If you have a building machines, building farm, whatever, which is building your code, it needs to be fast. It needs to be very, very fast to get the feedback to the developer, because the developer is in one context now, and when he or she pushes that code to the repository, they stay in that context for a very little time. And if the feedback arrives when they are still in that context, they can still act on it without having to switch contexts back and forth again. So how do I scale builds? How do I build faster things? We're going to get a bit technical here. I believe some of you know this guy. That's Mr. Jenkins. He's responsible for building our stuff. Maybe this technology is familiar to you. That's Docker. And maybe this. By the combination of these three, you have the possibility to scale your builds. You have the possibility to run parallel builds cost efficiently, without any hassle, and in a clear and structured way. Container technology, for those who don't know, containers are an awesome way of doing software development work. And they are especially useful in building stuff, because when you are building stuff, you usually have a lot of dependencies. You have operating system dependencies, you have your application system dependencies, and sometimes those two, you cannot have two versions of the dependencies at the same time at the same machine, or at least it gets very tricky. Containers are a way to pack those dependencies into an image, and that image can be then run anywhere. So once you get those dependencies set up, you can run your builds anywhere, in any machine. Windows is also supported. And the wheel there, it's Kubernetes. And Kubernetes enables these containers to run on multiple machines, so that you don't even have to think about it. You don't even have to think about which machine is going to run this build. You just tell Kubernetes, please run these containers, and yeah, that's it. You can just throw workloads to the Kubernetes, and it will take care of running those. It will take care of the allocation of the resources, of the or what should the container take. And when you combine these three together, you're going to get a very fast, very efficient build pipeline. It works like this. The Jenkins is going to tell you, Kubernetes, I need these containers set up and running. And then the Kubernetes will start to spin up the containers. As many as you want, only limited by the hardware that is running under the Kubernetes. And this way, you can scale almost indefinitely. If you're running in cloud, you can scale the Kubernetes cluster up and down. How many machines do you want, do you need? And you can calculate how many machines do you need in order to run those builds. This is all a bit technical, so let's do a quick demo. I'm going to build a game. I'm going to build a game to Windows and to Linux at the same time using containers. It's a game coded in Golang, and I have two containers. In one container, I have all the dependencies that are required to build the game for Windows. In another container, I have all the dependencies that are required to build the game for Linux. And by the end of the build, the artifact from the build, meaning the binary, gets uploaded to a cloud storage in Google Cloud. let's look at how it goes. So running the build, and this is Jenkins. So what happens now is that the Jenkins is going to ask the Kubernetes spin up these containers, and in the pipeline file that I show you here, I have a parallel build which is telling that you should run these two tasks parallel to each other. And they will, and they don't even care about each other. Both of these containers are now running in the Kubernetes, and it's running the build. It's collecting the dependencies, which I would have collected earlier, but they're changing all the time. So it's collected the dependencies to the container. Then it's going to run the build by running the instructions sent by Jenkins. This is, by the way, running in the Google's Hamina data center. And when you're running these parallel builds, you can run anything here. You can run test automation in parallel. You can run these cross-platform builds in parallel. Anything that you can think of to speed up the build process. And when you're thinking about developer experience, it's paramount to know that, yeah, your code worked in Windows all right, but the Linux build crashed. And when you combine this with the QA environment, it doesn't interrupt anyone's work because you can fix it. And when you think it's good enough, the build passes all right, then you can show the tester that this is the QA environment, and now you can go and test it. So the Linux build it has finished, and it has uploaded the artifact to the Google Cloud, and the Windows is still running. And if you have let's think about some special hardware requirements, like I want to run this on Windows, I want to run this on a server that has GPUs, no problem. Kubernetes can take care of that. So the build is now finished. And if I go to the Google Cloud Storage, which is now empty, and press refresh, I should have both artifacts here. There we go. So this is the Linux version of the application, and this is the Windows version of the application. This is kind of the QA environment, because now everyone has access to it. I can download the Windows version right here, and I can share the link to everyone inside my team. Hey, I just built something. Can you please go to this address and test it? Instead of zipping the binary that you compiled in your own machine, and then you probably emailed it to someone, and it's total hassle when you compare it to this. So that's how you run parallel builds in Jenkins. Let's take a look at the future. This is more of a backend side, but with a little thinking, some of these ideas can be applied to the front side as well. Traffic mirroring is a feature. Actually, all of these are features of the tool called Istio. Istio is a service mesh for Kubernetes, and it's made for running web services like backends or in the Kubernetes. And the traffic mirroring is one feature when let's think about you're running Canary version. You're running Canary version in production, but you don't want to mess with the users. That 10% of the traffic, you don't want to reply to the users that how did your request went. You want to have the old version still responding to the users, but you can mirror like 10% of the traffic to a new set of servers that are running the new version of your application, and you can monitor the application safely inside your walls and see how it performs. This is especially useful when you are thinking about some service that is doing maybe some calculations or some analytics. If you deploy a new version, you can see is it faster than the current one in production without interrupting the users. Adaptive sampling is something that's still coming up. As I said, you have to collect metrics. You have to collect metrics of your application. You have to collect metrics how your game performs or how your application performs. But how many metrics? If you have millions of users, that's a whole lot of data you're going to get. Adaptive sampling is something that enables an algorithm, and that algorithm monitors the performance of the game or the application or the product. And if it sees this, there seems to be some problem with the application. It can increase the logging levels, it can increase the metrics collection, it can increase the sampling rate of how many metrics should I collect, what metrics should I collect, and then send those back to you. So even if you don't know how there's a problem, some of your users know there's a problem, and you go to work, and you get to work, and you know there's a problem, the users are complaining that, you already have the debug data sent to you by this algorithm. Fault injection, my personal favorite, is something that you have a beautiful setup in the back end. You maybe have a few services communicating with each other. It's quite complex, you are very proud of it. But now and then there's a problem. Some user do something bad, or there's a network problem. You can deliberately send faults to your network. And by sending these faults, meaning like you're responding with wrong HTTP code with now and then, you're going to see how your infrastructure can tolerate failure. Does it even end up in the logs? Are the users going to see there's a failure? And this is especially useful in test automation cases, where you can just randomly throw stuff at your services and see what comes up. Last but least, circuit breakers would be useful in if you have multiple data centers, or in a Canary deployment. Once again, in Canary deployment, if you're running circuit breakers, you could set the circuit breaker in front of the Canary version that is serving the 10% of your users. And you could set the circuit breaker so that if the error rate is 100%, if all the requests will fail when they end up in the new version, stop the traffic and let's go back to the old version. Circuit breaker is also useful if you have multiple data centers, because if you have a network fault in one of the data centers, you could set up a circuit breaker in front of that data center, and the circuit breaker will know, okay, there seems to be a network problem with the data center. Let's cut off traffic there, and let's redirect traffic to the one data center that we still have. So that's Istio. Some of these features are available right now. Some of these are still coming up. They are mostly for the back end, as I told you, but they have its uses in the front end as well. So that's it. Thank you for coming, and any questions?
All right, so any questions, comments? No, none? All clear? Excellent. Niklas, thank you so much.
Thank you. Thank you.